Good morning, ladies and gentlemen, and welcome back to your SAT Math Prep session here for the week of November 29th, 2021. We are going to be dealing with quadratic functions again this week, same thing we worked on the last time we were together. Once again, I'd like to note that it is extremely important that you write your complete name, first and last name, up here on the name line accurately, and so I can read it. Please make sure you circle your teacher's name. If you have more than one, circle both. Same thing over here with the classes you're in. If you're in more than one, circle them. So, example 1 says, if A is a solution to the equation shown below and A is greater than 0, what is the value of A? So A is a solution, which means we need to solve the equation. So what we do is we look at that and we ask ourselves, can it be factored? Are there numbers that multiply to negative 12 and add to positive 1? Okay, that's C and B. Because we want to find those numbers because those are the numbers that go into our factors. So if we look at our options, there's only one option, only one set of numbers that multiplies to negative 12 and adds to positive 1. That is positive 4 and negative 3. So this trinomial factors into x plus 4 and x minus 3. The zero factor theorem then states that one of those two factors has to equal 0. So either x plus 4 equals 0 or x minus 3 equals 0. So that allows us to solve and get both of our answers. The first equation, we would subtract 4 from each side. The second equation, we would add 3 to each side. That gives us solutions of x equals negative 4 and x equals positive 3. Now the key here is the question, okay? A is greater than 0, what is the value of A? Well, A is greater than 0 means it is positive. So if we look at our answers, we have a positive and a negative answer. And this thing says that A is the positive solution. So the positive solution would be 3, meaning that A is 3. Example 2 says the length of a rectangular tile is 4 inches longer than the width of the tile. If the area of the tile is 60 square inches, what is the length of the tile in inches? So we should draw a picture here. We have a rectangular tile. We do not know the width, so we're going to use W for that. We also do not know the length, but we do know that the length of the rectangle is 4 inches more than the width. So we can take that and we can write out the expression W plus 4 to represent the length. So W plus 4 is our length. Now, from there, we're looking at an area equation for a rectangle. Now, you are expected to know that the area of any rectangle is length times width. Now, we know that the area is 60. So that number goes in for area. 60 equals our length, which is W plus 4, times our width. Then we're going to solve that equation. Well, that requires us to distribute. So we distribute the W, gives us 60 equals W squared plus 4W. And then we need to move the 60 to the other side of the equation because we can't solve a quadratic equation by factoring unless it is equal to 0. So that gives us 0 equals W squared plus 4W minus 60. Which means we are looking for two numbers that multiply to negative 60 and add to positive 4. They need to multiply to C and add to B. Well, that would be W plus 10 and W minus 6. Again, that means we have two possible algebraic answers to that equation. W plus 10 equals 0 or W minus 6 equals 0. Set each factor equal to 0. Then we solve. Well, if we subtract 10 from each side of that first equation, we get W equals negative 10 And if we add 6 to both sides of the second equation, we get W equals 6. Now this is a context of the problem issue. We have two possible answers. The question is, which one is the correct answer? Well, width can't be negative. If W is the width, it cannot be negative. So we're not going to use that negative 10. Our answer is going to be W equals 6. That means the width is 6 inches. Now we weren't asked for the width though. We were asked, what is the length of the tile? Well, that would be 6 plus 4, or 10 inches. C. Okay, example 3 says, in the xy plane, the graph of the function f of x equals x squared plus 10x minus 24 has two x-intercepts. X-intercepts, you should immediately think roots, solutions, zeros. All of these words mean the same thing. What is the distance between the x-intercepts? So what we need to do is we need to solve the equation 0 equals x squared plus 10x minus 24. We need to know when f of x, when that function crosses the x-axis, which would be when y, or f of x, is equal to 0. So again, we're going to factor that. We need two numbers that multiply to negative 24 and add to positive 10. That would be positive 12 and negative 2, which means we have two answers, x plus 12 equals 0, or x minus 2 equals 0, one or the other. In each case, we're looking at a one-step equation, so we would solve those equations by adding 2 to each side in the second case and by subtracting 12 in the first case. Gives us our two answers of negative 12 and positive 2. It says, what is the distance between those x-intercepts? Well, those x-intercepts lie on the x-axis. Negative 12 is way over here. I really wish I could get the sensitivity right on this. Negative 12 is over here. Positive 2 is to the right. And you just have to think to yourself, how far is it from one to the other? Well, that is 14 units between those two. So the correct answer is D, 14 units. Now think about, where are those two x-intercepts located on the number line that is the x-axis? How far apart are they? Well, those are 14 units apart. If you counted with your fingers the lines between negative 12 and positive 2, there'd be 14 lines. Okay, example 4 is a bit of a stretch. It says in the equation below, k is a constant. For which of the following values of k does the equation have only one solution? Well, this is a very tricky question. This is basically asking you to plug in a number for k to create what is called a perfect square trinomial. That is, we want the k value that would lead to the same factor twice. And I will just go ahead and we're just going to jump in here. We're going to say, well, if k is 4, the numbers that multiply to 4 and add to negative 4 are negative 2 and negative 2, meaning we have the same factors. Well, if we have the same factors, then when we set them equal to 0, we end up with the same equations, which means we have the same solutions, which means there's only one solution. So the correct answer is k is equal to 4. Now if you plug in these other numbers, yes, these do factor. Well, in most cases anyway. X squared minus 4x plus 5 doesn't factor, but minus 5 does. That would be x minus 5, x plus 1. Well, that's two different solutions. So that's not the right answer. If we had x squared minus 4x minus 12 equals 0, that does factor. But again, those are not the same factors, so that would have two solutions. The same would go for positive 5. They would not be exact answers, but there would be two. You're looking for the number that when you plug it in, which k value results in the same factors and therefore the same solutions. Okay, so on the back are a couple of examples for you to try on your own. Again, you know the drill by now. Make sure that you show your work. Make sure that your name is on your paper. And when you get done, or when the period ends, whichever comes first, turn your paper into your proctor. Your paper needs to be turned in before you leave plug time, and it needs to have your name on it. Thank you very much for your time and attention.